All right, guys, what's happening? So today we're going to be talking about parallel lines cut by a transversal. I will explain that. First, I want you guys to warm up with this real quick, and we'll get going. All right, here we go. The measure of angle 1, measure of angle 2, measure of angle 3. That's what you were asked to find. Let's see if you did it right. Well, first thing you know that 40 degrees and whatever measurement this angle turns out to be, well, these two angles are vertical angles. And what do we know about vertical angles? Well, we know that they are equal to each other, right? So if this angle measures 40 degrees, so does this one. So the measure of angle 2 is 40 degrees. Okay? All right, we also know that angles that are adjacent to each other like this form a linear pair. So we know that these two angles added together make this straight line right here. So if this angle is 40, and you add it to another angle to make a straight line, the total number of degrees of that angle is 180. So if this angle is 40, we need 140, okay? So 140 degrees plus 40 degrees equals 180 degrees. That's the measure of this angle forming the straight line. And then if we know that this angle right here is 140, well, look above it. Isn't this angle up here also then 140 because they are vertical angles? So these two angles are equal 140. Okay. All right. So remember those names, those angle relationships are called. We used vertical. Okay, and we used linear pair. Okay, linear pair. All right. So that's what helped us get those things. But again, just be aware of those names, but mainly you can probably figure those out in your head just by looking at it, okay? Notice this angle right here is a big old obtuse angle, and so is this angle down here. It's a big old obtuse angle. Those guys match, don't they, okay? These guys up here match. It's easy to see that these guys are the same size, okay? And likewise with these angles in the middle here, okay? All right, now let's talk about parallel lines cut by a transversal. What do I mean by that? Well, hopefully you know what parallel lines are. All right, so let me just give you an example of parallel lines. Here is one line, and look at this. I'll use my ruler and just draw it on the other side. Those lines will never intersect. They are parallel, okay? And I usually put little arrows on the ends of them so you guys can see. And what I mean by cut by a transversal is something like this, okay? This is a transversal. This line cuts across both of those parallel lines, okay? And so what you're going to need to know is some vocabulary, all right? And that's what's going to start to get confusing, is all of the different vocabulary terms you will need to know, okay? But hopefully you'll be able to kind of like get around that by just being observant, okay? Remember how we looked up here, we saw that this angle over here was the same size as this angle, so you know that they're going to be equal. So do you need to know that they're vertical angles? Yes, but more importantly, you should be able to tell me that these angles have equal measure. Okay, look at these, okay? Do you see any angles that possibly have the same measure? Okay, well, don't you see that this angle right here and this angle right here are vertical angles? But look at them, don't they look to be the same size? Okay, they are. So you should be able to see, okay, that certain angles are the same, okay? But if you look over here, look at this angle shape right here. Look at that angle shape right there, okay? You see that? Look at this angle shape right here. Look at that angle shape right there. You see this angle and this angle right there? Don't they look to be about the same size? Okay, that's because they are, okay? And there's a name for angles like that, okay? There's a name for angles like that. They are called corresponding angles, okay? Corresponding angles. Okay, corresponding angles are going to be equal. Just like vertical angles are equal, corresponding angles are equal, okay? And I'll list corresponding angles. This is how we do it. This is angle 1. This is angle 2, this is angle 3, this is angle 4, this is angle 5, 6, 7, and 8, okay? All right, I've already pointed out two corresponding angles, this angle 2 and angle 6. So I know that angle 2 and angle 6 are corresponding angles. And we also know that they are going to be equal to each other. So the measures, okay, are equal to each other. Do you see any other corresponding angles? Okay, well, look at this. I see angle 1 corresponds with angle 5. So if you think about it, if you look up here at this cluster of angles, those 4 angles, and you look down here at this cluster of 4 angles, do you see what angle from this cluster corresponds to the angle from this cluster? Okay? What angle up here matches the position of the angle down there? Okay, that's what it means by corresponding. Okay, so if I said angle 1, okay, so angle 1 is up here in this cluster. Which angle corresponds with angle 1 from this cluster? Okay, that's right, it's angle 5. Okay, so since they're corresponding, look at it. Angle 1 is a big old obtuse angle, isn't it? Look at that big obtuse angle. We have the same thing here, a big old obtuse angle. So those guys are going to be equal. Their measures are equal. The measure of angle 1 equals the measure of angle 5. There are more corresponding angles, okay? But I'll let you do that on your own. So there's a couple just to get you started. Those are corresponding angles, okay? Now let's talk about something called alternate interior angles. Let's talk about alternate interior angles. Okay. All right. Alternate interior angles. This is what I'm talking about. Alternate meaning on alternating sides of the transversal, and interior meaning on the inside of the parallel lines. Okay. So I'm talking about angles that are numbered 3, 4, 5, and 6. Those guys are on the interior of the parallel lines. 3, 4, 5, and 6. Now, we're always going to take an angle from the top cluster and match it up with an angle from the bottom cluster. Okay? So if I take an angle from the top cluster that's on the interior, I'm only looking at 3 and 4. Okay? So let's just focus on 3. All right, let's focus on 3. Okay? Can you tell me, if I'm focusing on angle 3 from the top cluster, which angle down here from the bottom cluster is on the interior, but on the alternate side or the opposite side of the transversal? Okay, well, let's narrow it down. If I'm looking at 3, okay, I want to find which angle is on the interior of the parallel lines, but on the opposite side of the transversal. Okay, so the interior angles would be 5 and 6. Okay, 3 is on the left side of the transversal, so 6 would be on the opposite side. So 3 and 6, angle 3 and angle 6 are alternate interior angles. They're both on the interior of the parallel lines, and they are on alternate sides of the transversal. Okay, so 3 and 6. But if you look, isn't 3 an acute angle? Isn't 6 also an acute angle? Remember, acute means less than 90 degrees. Okay, so they're going to be the same too. Their measures are going to be equal. Okay, what's another pair of alternate interior angles? Okay, what if I said angle 4? What would you say that 4 matches up with? That's right, it's angle 5, and they're also going to have equal measures. Look at 4. Isn't that a big old obtuse angle? Isn't 4 a big old obtuse? And look at 5. That's also a big old obtuse angle. Okay, so we have corresponding angles, alternate interior angles. All right, let's talk about, let's skip same side interior angles really quick. Let's go to alternate exterior angles, okay? All right, alternate exterior angles, all right? Well, what do you think that means? Well, if alternate interior angles were angles that are on the interior of the parallel lines, well, then alternate exterior angles would be angles that are on the exterior of the parallel lines. So we're talking about angles 1 and 2 and 7 and 8. All right, so what if I said, hey, find me an alternate exterior angle for angle 1, okay? Well, I have only 7 and 8 to choose from, but it says alternate, so it has to be on the other side of that transversal. So 1 and 8. So angle 1 and angle 8. And if you look at them, isn't 1 an obtuse angle? Look at 8. Isn't 8 also obtuse? Okay, so I know that their measurements are equal. Can you find the other one? We have angle 2 matches up with angle 7. Okay, acute, acute, they're the same. Okay, all right, so these guys right here, if you notice these angle relationships, they are all equal to each other, right? Okay, I'm going to give you one more curveball. Here we go. How about same side interior angles? Okay, same side interior angles. All right, well, again, we're talking about interior angles, so what do I have to choose from? 3 and 4 from the top cluster, 5 and 6 from the bottom cluster. It says same side interior. So what if I said, hey, tell me about angle 3. What would be the same side interior angle? Okay, well, 3 is up here, so we have to look down here. So on the interior, I have 5 and 6. Okay, but I want the same side interior, so which one makes sense? That's right, it's 5, so angle 5. Now, here's the difference between all these guys. If you look at it, what kind of an angle is angle 3, right? Isn't that an acute angle, less than 90 degrees? Look at angle 5. Isn't that an obtuse angle? So can you say they're equal? No, you cannot say they're equal. But remember up here, when these two angles were equal, okay, they're vertical angles, they were equal. But what about the ones next to each other? What did you learn about those? That's right, they added up to 180 degrees. So that's the same thing with these guys. So these guys, if you add their measurements, sorry, I should say the measures of these, if you add them together, guess what you get? 180. Okay? Tell me 2 more same side interior angles. Okay? Well, the other interior angle is 4, so the measure of angle 4 matches up with, remember, same side interior, so it's going to be 6. So the measure of angle 6, if you add those 2 together, guess what you get? 180. Okay, so you're going to have to remember these terms. Okay? All right, let's do a couple practice problems. All right? Let me just give you a couple parallel lines here. All right, and I'll cut it with a transversal. All right, and here's what you need to know. This angle right here is going to be, I'm just going to say 50. Okay, that angle right there is 50. I want you to find 1, 2, 3, 4, 5, 6, and 7. Okay, I want you to find those guys. So the measure of angle 1 equals, the measure of angle 2 equals, and so on. Okay, all right, we'll see you in a sec. All right, so the measure of angle 1, look at it. Isn't that across from the 50? Aren't they both acute angles? Okay, so you know that those guys are going to be the same, right? So the measure of angle 1 is 50. Okay, they're vertical angles, but more importantly, what I want you guys to do is look to see, is it acute or is it obtuse? Okay, so the quick, easy way to do this is match up all the acute or all the angles that are that match the size. Okay, so watch this. I'm just going to list them. Angle 3, measure of angle 4, measure of angle 5, measure of angle 6, and measure of angle 7. Okay. All right. Now watch this. 50 is an acute angle. So 1 is the acute angle, so I put 50. Okay. Where's another acute angle? Ah, look, it's 4. So 4 matches the 50. They just happen to be alternate interior. Okay. They're alternate interior, but more importantly, look at the size of them. That guy matches the size of that guy. It's easier that way. Okay, what other angle is an acute angle? It's 7 right here, so that's also 50. Okay, all right, and that's it for the 50s. So now let's figure out the measure of angle 2. Well, remember, this guy is next to this guy. What did we say about those guys that are next to each other that form a straight line? They add up to 180, don't they? All right, so this guy right here plus 50 equals 180, so this guy has to be 130. Okay, now watch this. This guy's across from this guy. It's also obtuse, 130. Do you see what the rest of them are? Okay, cool. I'm going to pause the video. I'm going to start a new one. See you in a sec.